Hi, welcome back. This is Math 1620, Calculus 2, 50420, Summer 23. My name is Mr. Stroop, and so let's take a look at what we got. Okay, so this here, if you look at the screen, I'm in Blackboard. You'll click on your class. Hopefully, you're enrolled in the correct class. I'll put up announcements every week reminding you of all the details of the class. And so the information tab here on the left is where you'll go to find all of the details for the class. There's my office hours, my email, where to find me on the web. These are your supplies. So the major portion of the homework will be in WebAssign, just to make sure. This is the only way I could really make sure that you're doing your homework, even though I know there's maybe workarounds there. But for now, it's a pretty good way for me to check your homework. So I'll be giving you homework there. I suggest you also do homework out of the book, though, and during the videos, I'll give you kind of homework lists there for practice. The calculator, you can only use a TI-84 plus or below on the test. The test will be taken in class. They won't be on the web or anything. So for grading, there's going to be the homework and WebAssign. Each section is worth 4 points. So you'll go here and you'll see, okay, 8.1, I got to do that. And it's worth 4 points in total if you get all of the problems. But you can get partial credit if you don't want to get an A in the class. If you don't care, you don't have to get 100% every time. You just sort of aim for getting 80%. So each one is worth 4 points. There's 29 assignments, so 4 times 29, I think it's 116. It will be the total amount of points for WebAssign. And you can see that in my little box here, my grading scale and stuff. Anyways, there's homework and WebAssign. At the end of classes, I usually give like a participation quiz just to make sure you're awake and doing your work. In each one of these videos, there will be kind of a quote-unquote video quiz. I'll embed it somewhere in the video, and you'll have to kind of watch for it. And once you see it, you write it on a piece of paper and just turn that in at the next class meeting. Each quiz is worth 2 points. Then there will be the written tests, of course, which are all going to be on paper, in class, just traditional type kind of tests. Usually I'll base the questions off the homework. And okay, so that's pretty much it as far as work is involved. So WebAssign, the tests, the little quizzes, and the video quizzes, and the final exam is comprehensive. Okay, so one thing to note for extra credit or anything like that, you really need to be participating in the class. So I had people try to kind of just use extra credit in order to pass, and that's not going to work anymore. So just make sure if you want like a drop test, which I'll drop your lowest test score. But if in order for me to do that, you have to get over 50% on all the tests. So you can't just, well, I'm going to flunk this one and be done with it. No, you have to really try on all your tests. You have to try all your homework. You can't miss more than 2 class sections. And honestly, because we do so much work, you shouldn't really miss any classes. And of course, cheating in any way will automatically forfeit any of that. Okay, so you won't be able to get any help whatsoever. And you have to have attempted all the homework as well. So you can't say, well, I'm not going to do any homework and he'll drop a test or something and I'll be okay. No, you got to do your homework in this class. So usually my tests are pretty simple, pretty straightforward. I'm not looking for you to split the atom or anything like that or be super creative. I'm kind of of the opinion that most creativity can be programmed, and so I want you to do the majority of your homework on your own, and then in class just show me the basics and it's also a test anxiety thing because at Tri-C we get a lot of students with test anxiety, so I try to put most of the emphasis on the homework, but I don't know. Anyways, the last thing is the schedule here, and you have a good idea. So if you want to, usually you should try to come to class somewhat prepared. When I played it in orchestras, I was typically there 15, 20 minutes early, sitting in my seat practicing. So I already knew what was going on going into orchestra, and then once we got the orchestra, I just worked on phrasing and that sort of stuff. So I kind of the same opinion now. You should be kind of at least breezing through the book. The book, you'll probably get an ebook, and you could, worst case scenario, and I know this is a summer class, you could just kind of breeze the topics in the book. So you just kind of go through and look at the headings, and at least you'll have some concept of what's going on when you come in the class. Sometimes the students will ask questions, and I'm like, whoa, you obviously have no idea what's going on. Don't be that student, okay? So sometimes better to not ask any idiotic questions than to make a fool out of yourself. But if you read the book, you're probably not going to make a fool out of yourself, right? So you'll know what's going on and kind of be on board. Please raise your hand in class before you ask any questions. Until we get some sort of rapport going on, generally you have to kind of raise your hand before you speak. Get my attention, don't just blurt things out, that sort of stuff. Okay. Anyways, yeah, that's pretty much it. I have the syllabus down here. I'll pass that on class today. I also have a grading Excel sheet that you can use and kind of populate it with your grades throughout the semester, and it self-populates, enable the editing, and it's all filled out for all the different points. So these are the quizzes we do every day. So if you did today's quiz, you put it in there as a 1, and you have 1 point out of 688 points possible. So you can see your points, and this is the total possible, and that's just the ratio. And we can fill that out. These are the video quizzes that you'll be turning in. That's my math lab homework in the middle there. And then all of the tests. We have 4 tests. I've been trying to make the 4th test take home, but we'll see how much time we have. And then the final exam is comprehensive, 150 points. Okay. Let's see. So you could use that. If, worst case, you can always email me and tell me you want to know exactly what your grade is, and I can send it to you as well. Okay, so that being said, the video, for right now, I'll just be kind of going through homework problems, and of course, there'll be the video quiz. In the future, if I don't have time to cover things in class, I'll try to kind of sneak those in on the video homework or vice versa. Especially when we get to chapter 9, I'll kind of put the proofs into the videos and not worry about them in class, because the proofs can be kind of long and time consuming. Yeah, that's about it. So I say let's dive in there and start chipping away at the material. 8.1 is on the basics of integration that you learned already in Calc 1, hopefully. If not, your previous professor may have screwed up, or you're in the wrong class. So let's take a look at 8.1. Of course, there's all kinds of basic rules. You need to have those rules memorized. So you don't know in what world you're getting away with not having to memorize formulas, but here you're going to have to memorize formulas. It just makes things a lot easier. Imagine trying to learn a language, but you never learn how to say hello. You have to look it up, like in Russian it's privyet or здравствуйте, or something like that. You got to memorize that stuff, right? So you're going to have to memorize certain rules. Again, I'll go over those in class. But what I want to do is just kind of go through, like maybe do every other problem here. If I don't catch them in class, and hopefully I'll catch them here, right? Okay, so let's look at number 2. Is my pen working? Work pen, please. Sometimes I hit the button and it doesn't work. It's like a weird drawing pen. Sorry. There it goes. And I hit it again. So okay. So number 2 is a U substitution with a power rule, right? So I have Z minus 13 to the 17 dz. And usually what you're looking for is kind of some parentheses, and then you're going to let your U variable equal whatever the heck's in the parentheses, right? So here I'm going to let U equal Z minus 13. And then the differential, the derivative, in other words, du, is going to be the derivative of z, which is 1. The derivative of negative 13 is 0. And then you just tack on the dz. Okay? So it's maybe a little bit different than how you were taught to do the u subs, but this is kind of what I want to see on the test. I'll be looking for your U sub. I'll wonder what happened if you don't show me the U sub. So please show me the U sub. It's pretty standard in all books. If you go to MIT, you know, maybe you're going to do it all in your head. But for us, I prefer to see the U sub, see the work. So I know you're not just using your calculator or something. Okay, so anyways, there's my U sub. Now I'm going to replace the thing in the parentheses with the U variable, and I'm going to replace the dz with du. Okay, so it's really only those 2 red boxes that I use for replacement. So I have 17 all over U to the 17, and then I'm replacing dz with du. Okay. So 9 times out of 10 for these simple integrals, you could apply the power rule. And to apply the power rule, I need to bring that denominator into the numerator and change the sign of the exponent. I'm also going to factor out the 17. So I like to pull out any factors that are not dependent on u. So I'm going to pull the 17 out in front. I'm going to rewrite 1 over u to the 17th as u to the negative 17, du. And then it's the power rule. So you add 1 to the old exponent. So I'll have u to the negative 16, negative 17 plus 1 is negative 16, and then divide by that exponent. So I'm going to go 1 over negative 16 here if you wish, and that will be that, and then plus your integration constant. And now I got to clean it up a bit, so it's going to be negative 17 over 16. U to the negative 16 plus c, and then you can drop the u to the negative 16 to the denominator, negative 17 all over 16 u to the positive 16 plus c, and then you need to back sub. Okay, so if you begin in x, or if you begin in this case in z, you need to end in z as well. Okay, so I replace u with z minus 13. That will be raised to the 16th, and then plus c. Okay, so let's move on here to number 4. So the integral of 6 all over e to the negative x plus 1 dx. And there's a couple ways you could approach this one. You can kind of add phantom terms. I probably do that in my notes in class, but another way to do it is just to multiply top and bottom by the same thing. Okay, so in this case, if I multiply top and bottom by e to the positive x, it's going to work out for me. Okay. So a lot of doing integration is just seeing lots and lots of integrals, doing lots and lots of integrals. If you know anything about the neural networks, that's kind of how they work, right? They train the computer on a bunch of data, so you can literally pump in a bunch of derivatives and use it as data for the computer to make guesses on the integral. For us humans, we just want to do lots and lots of homework. So anyways, yeah, we have the integral of 6e to the x. Downstairs, if I distribute, I'll have e to the x times e to the negative x. And in those cases, you add the exponents. So it's e to the x minus x, which is e to the 0, which is just 1. Right? So I'll have e to the x times e to the negative x is 1, and then plus e to the x dx. Okay, now I can do a u sub, and you couldn't initially do the u sub. Maybe it wasn't obvious. You may have had to play around with it a little bit, but the problem in the beginning, you would have been left with that dz portion, or in our case, the dx portion equaling some factor of e to the negative x. And you couldn't get a cancellation when you did your sub to get it all in terms of u. So one of the main important kind of gateways in doing a substitution is that you want to eliminate the old variable. Okay. So anyways, here, if you let the denominator equal your u, and you get your du, the derivative of 1 is 0, the derivative of e to the x is e to the x, and then you tack on a dx. Then you solve for dx by dividing both sides by e to the x. You'll have du over e to the x. And the magic of this is that the e to the x in the numerator will cancel out. So here I go. I'm replacing u with 1 plus e to the x. I'm replacing dx with du over e to the x. And then there's a nice cancellation of the x material, right, which is what we need. I then can factor out the 6, and I have 1 all over u du. That thing right there is our natural log integral. So that's a natural log of the absolute value of u. So I have 6 ln absolute value of u plus c. And then finally, you just back sub. Okay, so it'll be 6 ln absolute value 1 plus e to the x plus c. Not a bad idea. Number 5. Number 5 has the form of one of our inverse trig functions, which we need to have those memorized, those forms. And not only that, it has a complete the square issue going on. I wonder if they'll give me a similar problem. All right, so 35 over square root of 4x minus x squared dx. Okay, so the sine inverse form is written 1 all over the square root of a squared minus u squared du, and that would equal sine inverse, or arc sine, if you'd rather, of u all over a plus c. Right. So you couldn't really do a u sub, so if you tried, you would see it would fail. And so you kind of have to default to the memorized forms you have. And when you see that square root in the denominator, it's usually kind of a red flag for an arc sine scenario or an inverse sine scenario. We need to complete the square, or transform the insides of this radical here. In order to complete the square, you need a leading coefficient of positive 1. So I'm going to rewrite it by factoring out the negative and put the x squared first. So I'll have negative x squared, and then 4x will become minus 4x. And then plus negative 4 over 2 is negative 2, and then 2 squared. So the number that you're adding and then immediately subtracting in is always b all over 2 squared. Okay, so my b value is negative 4. Negative 4 over 2 is negative 2. Negative 2 squared is 4. Okay, and then I want to immediately subtract or get rid of it is probably a better way to think of it. You want to find its additive inverse. You've not really added in 4 though, right? Because if you have that negative in the front, what you've added in is negative 4. So rather than adding in, or rather than subtracting another 4, you're going to add in 4. and that will cause kind of a cancellation, and then you could get back to where you started if you needed to. Okay, so anyways, then we can now rewrite it and make it look a little bit more like the arcsine. So in the denominator, I'll have reordering with the 4 first, 4 minus, and then factoring the x squared minus 4x plus 4 will give me an x minus 2 squared, and then dx. Yeah, now it's completely in the form. The u expression is x minus 2. Du will just be dx. So derivative of x is 1. The derivative of negative 2 is 0. The a value is 2. So you just take the square root of the leading term inside the radical. Then we can factor out a 35, and everything else should be in the form. Okay. Now we apply the formula, so that would be 35 sine inverse of u all over a is 2. And then we could back sub. And we should be good to go. Evaluating integrals is very, very important. Let's put the video quiz in here. So this will be number 60 from the book. There's also the video quiz for the day, and you have to figure this out. Oops. So that's sine squared of t, cosine of t, dt. All right. So you should put that on a piece of paper, and the next time you come to class, you should be handing that in. And I will grade it. It is worth 2 points, and I will get it back to you. Please show work. Please do not just go on the web and get the answer that way. Usually I can kind of tell if you're using the computer. Please do not do that. You're only cheating yourself. Okay? But anyways, there's the video quiz. Let's try number 6. Okay, so I need a u sub, and usually for the u subs, just go to the parentheses and see whatever's in the. So the 20x is going to be it. Du is 20 dx, and then solve for dx. So I just get a constant 1/20 times du. When I do these kind of integrals, what I like to do is just drop the limits of the integral. So drop the 2 numbers that are attached to the integral symbol there. And then I'll get cosine of u times dx, which is now du over 20. Then I can factor out the 1/20. I'll have the integral of cosine of u du. And then cosine of u, I should have that integral memorized. And the integral of cosine is sine. And remind myself to evaluate, but you don't evaluate just yet. You need to back sub before you can put in the limits into the antiderivative. Okay, so it'll be 1/20 sine of 20x. And I need to evaluate from 0 to pi. So now I can put the limits back into the problem. Okay, so I have 1/20 sine of, now evaluate the antiderivative, first starting at pi over 40. So it's the fundamental theorem of calculus, minus the antiderivative evaluated at 0. Oops. And that first one, it's 20 times pi over 4. Sorry about that. So I totally butchered that. So 20 over 1 times pi over 40. I'll simplify that in a sec. And then the second guy, sine of 20 times 0. So that'll be 1/20th sine of pi over 2 minus 1/20th sine of 0. And of course, this will be then 1/20th. Sine of pi over 2 is 1, sine of 0 is 0. So if you wish, 1/20th times 1 minus 1/20th times 0, which of course is 1/20th. Okay, let's move on. Let's try number 9. That looks quite intimidating. So the integral of 11 tan x times the ln of cosine of x. We need some more parentheses, maybe? No. All right. Right, so the u sub here isn't quite clear. Usually I'm going for the innermost parentheses and just doing a u equals whatever. Here, it doesn't seem like that's going to get me anywhere. Because if you do a u sub for cosine, the du will be negative sine, and then you're not going to get cancellation. But if you're familiar enough with the derivatives, you might think to yourself, well, if I took that derivative of ln of cosine, I might get something like tan, right? So let's take a look. If I let u equal the ln of cosine, what is its derivative? So for ln's, it's always 1 all over the guts times the derivative of the guts. So you just tack on the derivative of cosine. That's the chain rule, basically. That would be negative sine x dx. And what the heck is that thing? That's just negative cotangent. And we need to get a cancellation with that tan, right? So that's going to work out. Whoops, sine over cosine is tangent, not cotan. So you need to have those kind of identities memorized as well. I'm going to divide both sides by tan, negative tan in particular. And I'll get negative du all over tan. Again, sine over cosine is tan. And then you're going to get a nice cancellation, right? So it's not so hard. You may have to fiddle around with your u sub a little bit to get your answer, but hopefully, I mean, they're not going to be giving you problems you can't do. So anyways, this is times u times dx, which is now negative du over tan x. Now I have to put those parentheses around those negatives, otherwise it kind of looks like you're doing subtraction, which is bad. You want to be able to do your work so other people, including yourself, can actually read your work. So it's one of the reasons I have for you doing turning in homework. I can factor out a negative 11, and I have the integral of u du. And that'll be negative 11. The integral of u is u squared over 2. Tack on your constant, and this will be rewriting a bit, negative 11 halves times u squared. Let's go ahead and back sub. That'll be ln of cosine of x squared, and then plus c. Okay. Oh, number 11 is another complete the square kind of problem. Let's try number 10. It's another one. If you try to do kind of a u sub, it's going to fail, right? So the correct approach is to use what's called a Pythagorean conjugate, which is kind of like rationalizing a denominator. It's going to multiply top and bottom by cosine plus 1. Okay. So in the numerator, you'll have 2 cosine theta plus 2. In the denominator, foiling, you'll have cosine times cosine is cosine squared. Outer cosine, cosine theta times 1 is cosine. Inner, negative 1 times cosine is negative cosine. So you have cosine minus cosine, which is 0. The inner and outer terms are additive opposites. They go away. And then negative 1 times 1 is minus 1. Okay. From here, what I'm going to do is substitution. So we recall these very important identities from trig, the first one, cosine squared plus sine squared equals 1. Then if you divide everything by cosine, you'll get 1 plus tan squared equals secant squared. And if you divided the original equation by sine squared, you would get cotan squared plus 1 equals cosecant squared. Okay. So we want an identity to replace the cosine squared minus 1. Okay. And that we'll use this first equation to do that. So if I solve for cosine squared minus, so if you just subtract 1 from both sides, and then subtract sine from both sides. So if I'm going to move the 1 over here and then move the sine over there. I'll have cosine squared minus 1 equals negative sine squared. And so I can replace the thing in the box with negative sine squared. Okay, then what? Well, now I can kind of butterfly this equation, or fillet it, if you'd rather think of it that way. I'll have 2 cosine theta all over negative sine squared theta d theta, and then plus the integral of 2 all over negative sine squared theta d theta. Then I want to put these into some form which is recognizable to me, and I can integrate it. So this first guy, I'm going to rewrite it a little bit by kind of factoring things about. So I'll have 2 cosine theta all over the negative, and rather than writing sine squared, I'm going to write sine theta times sine theta. Okay. You could factor out the negative 2, so you could, if you wish, just move the negative out, move the 2 out, you get negative 2 integral. It looks like cosine theta over sine theta. So you're kind of just putting it like that, and then you can put the 1 over sine theta. And I lost my d theta somewhere. And then you could rewrite that as negative 2 times the integral of cotan theta times cosecant theta d theta. Okay, so that first integral, just doing a little bit of trig, is going to be negative 2 integral cotan theta cosecant theta d theta. And then the second integral, you can also pull out a negative 2, and you get the integral of, well, what the heck is 1 over sine? 1 over sine squared in particular. That's just going to be cosecant squared. Okay, so you'll have in the integral cosecant squared. And these are elementary integrals that you should have memorized. So the derivative of cosecant is negative cosecant cotan. So you have negative 2 times negative cosecant. And then the second guy, the derivative of cotan is negative cosecant squared. So this will be negative 2 times negative cotan. Okay, cleaning up a little bit, yeah, 2 cosecant theta plus 2 cotan theta plus c. Okay, we could try one more. We'll try number 12, and then we'll call it quits for this video. So here you need to do a U sub to get the job done. And maybe you're thinking, well, this must be one of those arc sines or something. But if you see a function and its derivative, you can almost bet that the function is going to be the U sub. Okay, so here, this thing, I'm considering the function, and this thing up here is its derivative. Okay. So there's going to be a cancellation when you do your subs. So I'm going to let u be the x squared plus 25. And then du will be, well, the derivative of x squared is 2x. Derivative of 25 is 0, so it's just 2x dx. and then you solve for dx. Okay. So we'll have the integral of 2x all over the square root of u times dx, which is du over 2x. I'm dropping the 0 and the 12. I don't want those when I'm working in terms of this other variable. So I'll have 1 over the square root of u. I'm going to rewrite square root of u as u to the 1/2 because I'm going to want to apply the power rule. Right? So 1 over u to the 1/2 is u to the negative 1/2. And then power rule it, u to the negative 1/2 plus 1 is positive 1/2. And then divided by 1/2 is the same as multiplying by its reciprocal, which is 2. Remind yourself to evaluate. So I'll have 2 times x squared plus 25 to the 1/2. And I need to evaluate from 0 to 12. And then you're plugging in those numbers. So this will be 2 times 12 squared is 144, plus 25 is 169 to the 1/2, minus 2 times 0 plus 25 is 25 to the 1/2. Square root of 169 is 13, square root of 25 is 5. This would be 26 minus 10, which is 16. Okay. Okay, so remember in every video there will be a video quiz you must watch out for, and then you'll complete that and turn it in the next class, and I will grade it and hand it back to you. So today's video quiz was question number 60 and I usually get the questions straight from the book. And that's also a good place to go in order to get some practice. So some good practice exercises, so when the test rolls around, it's not a bad idea to go back there and kind of do some extra work. Problems like 3 to 45 odd, and then 57 to 71 odd. And if you really want a challenge, you can look down here at some of these problems, some of these challenge type problems, and you learn a lot more about doing derivatives and integrals in the exploring concept section. So I'll leave that to you, and thank you for watching, and we'll see you next time.